Hi everyone. Let's talk about solenoid valves. I just recently bought one from China. There's many types, but this one is using diaphragm and it's pilot operated. Let's take a look at the specs. DC 12 volts. There's a minimum pressure and a maximum pressure, which MPa, which is 10 bars. So this can handle 8 bars. It's so tiny, so it's quite okay. From the outside, what we can see is that there's a there's only one direction. It's like two ports. You can see this port, this is the inlet and this is the outlet. And for the electricity, for the electrical side, there's two contacts. So you can put DC inputs in either of these two, so it will work. What it does is, okay, it's a solenoid. Solenoid means that there's a electromagnet inside here. So when you energize these two contacts with 12 volts, it will turn into a magnet and it will pull something inside here to there will be like some kind of iron core which will move. Oops. Okay, and then next, diaphragm. I was like tinkering with this thing, just checking out how it works. And then diaphragm, what it means by diaphragm, it means that there is a rubberized kind of thing here that will be blocking the flow. So whenever you activate the solenoid, it will move out of the way through some ways. So it's also pilot operated, which means that it will use some of the pressure from the inlet side to open up the valve. So you don't really need strong springs for that. Without further ado, let's go look at the insides. Okay, the first thing I noted when I opened one of these is how soft the springs are. See, it's supposed to be able to handle 8 bars. 8 bars is quite a lot. Like your car tires are like 2 bars and 8 bars is like shop compressor. So it's just so soft. It can handle 8 bars. So look at this. Next, you can see the diaphragm. Oh no, there's 2 holes here. Oops. That's the diaphragm. We'll talk about the holes later. Next, this is the body. You can see that there's a there's a thing here. This is connected to the outlet, which is this is the outlet. It's connected to the outlet, and then at the area around this thing is connecting to the inlet. So okay, for what the diaphragm does is there's like 2 holes here. See, 2 holes. The 2 holes will allow some areas to the pressure to move across the diaphragm, and then when it moves to the other side, it can also like press it down or lift it up. That's all. Oh, let's check it. So this is the iron core. Okay, we'll move the springs out of the way. It's like there's another spring here, also pretty soft, very soft. Okay, so what this does is when this solenoid is energized, it will pull this iron core inside. It will pull it up. And then when you de-energize it, it will spring back out. And as it springs back out, it will close the middle hole here. This hole is just to equalize the pressure from the inlet to the above the diaphragm. I'll discuss later how it might work. Let's try this. Wires, contactors. Okay, so this is the thing here. Let's zoom it in. Hey, too much. This is a battery from 12 volts from a drill, also Chinese drill. So I put the contacts here, see, and when I release, it comes back out because of the spring. So this is what will close the middle hole here. Oop, get it to zoom. Yeah, so it will close the middle hole here. Okay, so here's a simple diagram of the valve. Here it is the inlet side, and that's the diaphragm, and then the diaphragm is covering the small elbow, the bend that goes towards the outlet side. So above here you can see that's the electromagnet, and then in the center of the electromagnet, a bit down because there's springs, that's the iron core. So the pressure from the inlet initially comes in and it leaks through that hole there, the hole in the diaphragm, to above the diaphragm. So the iron still closes the hole because there's two holes. So the iron closes the holes in the center, the hole in the center that leads to the outlet side. But then the outlet side has no pressure, but the inlet side has pressure and above the diaphragm. So this is a pressure difference. This will push the diaphragm harder into the opening here at the center. So the diaphragm is pushed down, there's no flow when the valve is closed, and it stays this way until it's activated. Okay, so next, when the solenoid is energized, the iron core will be pulled up, and then when the hole is open, the pressure from above the diaphragm will leak out to the outlet. So there will be a pressure drop above the diaphragm. Meanwhile, the pressure from the inlet below is still maintained. So the pressure difference here is the opposite. The pressure below the diaphragm is higher, while the pressure above is lower. So this pushes the diaphragm up, and then when the diaphragm is out of the way, the pressure from the inlet can just freely flow to the outlet. So in this case, the valve is open. Okay, once you de-energize, all the springs will push things back to the original position, and you can repeat it again. So for this kind of valve, you can see that there's no throttle because it's pilot. So it's either fully closed or really fully open. It's like 0 to 100. There's no, you cannot throttle it like a needle valve. Also, because it's the fluid having to move through the tiny holes in the diaphragm, it's very crucial that it's not blocked. So this is not suitable for particulates in the fluid like dust or sludge or anything. So that's all about this. Hope you enjoy, and see you next time.